So let's start this module two. The first lecture that closed module one in open module two is done by Dr. Quaranta. You will have in the first 2 hours, and he will give you a lecture on how to prepare a technical report. This lecture will be useful because those instructions are also on how to write the final activities of the course.
Especially that.
So
yes.
we thought usually do it as a last lecture of module one, but we had a lot of lecture last week, so we put it as first of module two. And then we start the lecture with Dr. Simoni from 11 a.m. as in the program that you receive. Riccardo.
Non sentiamo più l'audio, Andrea.
Ok, adesso mi sentite?
Sì, adesso
Perfetto.
sì.
Era involontariamente chiuso il microfono. Ok. Voi ancora vedete lo schermo, giusto? Sì. Perfetto.
Sì.
Va bene, allora riprendiamo. Grazie.
Guys, I will be back this afternoon to close the day. Enjoy your first day of biomodule. See you later.
Okay, thank you. Bye, Andrea. All right. Morning, everyone. Is there anyone new from last week? Okay, good. Nice to meet you, Riccardo. Manuel. Okay, so I guess you're Italian.
I arrived a bit later the best day, somewhere.
Okay. All right. So, for those of you who haven't met me, Andrea already introduced me. I'm part of the directive board of the master. I'm also lecturer sometimes. And today we will spend a couple of hours, maybe a little bit less than that, on how to write technical papers, technical reports, and this is particularly important for your thesis. Some of you are not academics, so some of you don't have an academic background, so this could be useful for them. For the others, those of you who have spent some time in a university, this is probably quite repetitive. You should know this already very well. So please bear with me if it could be a little bit boring. For the others, this could be a good chance to understand how things have to be written in an academic environment. So I'm pretty sure that those of you who already work in CBRN or are about to work in CBRN, this is something that you normally don't do. So that's why we want to spend these 2 hours in order to give you some ideas on how to write something, because you will have to write reports at the end of different modules as homework, and you will have to write a final thesis. And these are academic works. So I will help you in prepare something that is sound and is accepted once you have to present it to the final committee, and then it is accepted by the university. So that's why today we will spend a couple of hours, probably less than that, and I will ask you to do a little exercise in groups, very simple one later, in order to spend about half an hour. So first, let's go through this presentation, which I call a guide to writing a technical report thesis. You will see that it's not very complex, but there are some details that have to be taken care of. So the first thing that we need to talk about is the scientific method. of course, working in CPRN or in general in the university, everyone follows what is called the scientific method. Do you know what the scientific method is? Those of you who studied science, like chemistry, physics, biology, engineering, probably know already what the scientific method is. Others might not have a very very clear idea of that. So let's first, in a few words, describe what the scientific method is. Well, the scientific method is the method that is used by the scientific community, so all over the world, in order to validate the results of any research. Most likely, by the end of these 2 years, you will write a thesis. You will write a thesis on something that you have been working on in these 2 years. It could be your work, your everyday work. It could be something else that is not related to it, but you are interested in that topic and you want to investigate it in a deeper manner. So in that case, you probably will have to go through these steps. So the scientific method is the approach adopted by the international scientific community in order to deal with questions and answer them, and then report, so publish the work and report these ideas to the world. The first step, and then we will see the steps one by one, is collecting information, make observation, and ask questions. What does it mean? It means that how do we start the process of investigating a physical phenomena, a chemical reaction, and so on? By looking at what's happening. Just a very simple example. Isaac Newton was sitting under a tree and an apple fell on his head. Well, that's an observation. By observing the apple fall from the tree, Isaac Newton started to think about the reasons behind this phenomenon. So the first point is always to observe what's around us. So in these 2 years, probably you will observe a lot of different aspects. So you will get to know a lot of different topics. Some of them could be interesting, and you might be interested in investigating that further. So then at that point, you will ask a question that could be, how can I use this in order to write a good thesis? Or how could I understand, how could this phenomenon help me to understand better something else? So the first step is always ask yourself something. Then we try to answer that question by formulating a hypothesis. The hypothesis is a testable explanation. So we need to test the idea behind our question. So when we ask ourselves a question, we always try to answer that. How do we do that? By providing a plausible answer to that. That also is testable. We need to be able to test that hypothesis. The concept of hypothesis comes from the fact that they have to be tested. Therefore, we design an experiment, okay? And this is particularly important in sciences such as chemistry, biology, or physics, but it applies to every single field of knowledge, even to literature and everything. So the word experiment is a test for the hypothesis, okay? It could be very different than the lab test. Before we conduct the experiment, of course, we need to find out what we expect from the test. Because when we design an experiment, when we design a way to answer our question and to confirm, support the original hypothesis, we are also expecting something. You would not do an experiment if you don't expect that the result is what it is. You want to test the speed of an object, well, you will get a stopwatch, you will get a meter or anything that you need, but then you have an idea of already what you're doing. You know that maybe the speed that you're testing is slower, faster than the speed of sound and so on. So when you test it, you know already what you should expect, okay? So that is our expectations, our expected outcomes. Finally, we can test our hypothesis by conducting the experiment. The experiment will provide either the result that we were expecting. So this is what should happen if the hypothesis is supported. So our original idea, our answer to the original question is probably likely correct, or the test that could provide us results that are completely different from what we were expecting. If so, we will draw conclusions. Okay, our hypothesis is not supported. So we need to change something. What could we do? Well, we could design another experiment. We could change the original hypothesis. The reason, the explanation behind our question could be completely different from what we got. So we need to revise the first part. If the conclusion is correct, so not correct, sorry, is supported, the original hypothesis is supported, our experiment provided the results, the outcomes that we were expecting. Therefore, it's time to report our findings. And that's where we are today. We will see how to do this. But this is not the end. In your case, it will be the end. So the thesis will be the end of your course, so that is done. However, in the real world, when there is the answer to a question, other independent scientists should test your results as well, until it's been tested so many times that our hypothesis is finally accepted. I will give you an idea. For example, we all know that I have a pen. If I let this pen go, what's going to happen? It will fall. We know that very well. We haven't tested it. But this is an accepted hypothesis because it's been tested so many times that by now we know that this is what we should expect. It is the same what now it's, for example, the theory of relativity or the theory of evolution. They have been indirectly tested so many times that we accept them as they are. However, once it's published and the hypothesis is accepted, this should be conducted again and again in order to validate more times this idea. Okay, so to summarize this, the scientific method is divided in 5 basic steps, which are the observation. Then we ask a question, we formulate the hypothesis, and the hypothesis should be a testable explanation that is based on logic or previous knowledge. If we already have some knowledge on the field, well, of course, the previous knowledge should help us in understanding the expected results. So then we will make a prediction based on the hypothesis, and finally we test the prediction or collect and analyze data. So there are different approaches. It's not always the design one experiment. Sometimes we just need to collect data and analyze it. By the way, I forgot to tell you, you will have this presentation, then it will be uploaded on the CBRN portal. So if you need, you can download everything later and the video of this lecture today. I also added a step that I call 2.5, background research. Between the question and between the hypothesis, we should have a look at what's happened already. I'm sure that everything that we think about today has been worked on already in the past. Everything that we do comes from something that was already done. So why should we start from scratch, start from zero, if we can already start from a few steps ahead? So the idea is to do some background research. We'll see this, what it means in a minute. Plus one feedback step. So at the end of the 5 basic steps of the scientific method, there is a 6th step that is the iteration. We are not happy with one single test. We need to iterate it. We need to do it many more times in order to check if the outcomes is what we were expecting, and so to refine our research. If not, we need to change our hypothesis or our test. Okay, so the background research, this comes from the idea written in parentheses, in brackets, under point 3, using logical or previous knowledge. So why is background research so important? And you will see that in every university advanced course, such as this one, such as a PhD, there is always part of the work that is background research. And you should write in your thesis that background research. What is it? Well, according to what said Isaac Newton in 1675, he said that he discovered what he was studying, standing on the shoulder of giants. This is, of course, a metaphor, but if you want to look far ahead, would you look better if you're down here or if you are on top of a giant? Of course, if you are on the shoulders of a giant, you can see much farther away. So this idea is just that look at the knowledge that is built below us in order to look further away. So background research is looking back at what has already been done and do some bibliographic research by reading scientific journals, by finding books that can be of interest for your research, by reading scientific papers, articles that must be peer-reviewed and must be refutable. So IF is impact factor, so only from journals that are refutable, not journals that are not considered, how to say, reliable, that do not provide realistic information. These ones normally are not considered good sources. We'll spend some time talking about how to cite the sources, but of course, if you want to find good information, you will avoid TikTok, Facebook. I should change this logo, it's an X now, but so there is one little trick, Wikipedia. I know that everyone uses Wikipedia because it's the first page that always appears when you search something on Google. So Wikipedia itself is not a good source. However, everything that is written in Wikipedia normally has a link to the external source that was used. So while Wikipedia itself might not be a good source, the sources used in the Wikipedia page might be actually pretty good, pretty solid. So before you start any research, and this again, this applies in particular for your final thesis, you will have to write an important research. So before you do that, always go online or ask us if we can provide you with papers, books, and so on. Always have a look at what's been already done in that field. Because a university commission is expecting you to have done some background research. So normally, the first chapter of your thesis is always some background research. We'll see the structure of scientific paper later, but it is important to show that you are not starting from scratch. In any field, you are studying gas masks. There are a lot of gas masks already. So what's the technology now? What do you want to improve? If you want to improve something in gas masks, you need to talk about what's the level now, the base level now, the state of the art. In that way, you know what you are providing extra. If you don't know what's out there now, you cannot improve the system. For example, this is just one example. You want to talk about the dispersion of radionuclides in the atmosphere after a release. Okay, good. What is the state of the art? What is the level of the study on dispersion of radioisotopes, radionuclides already now? Why should I do something that is already there? I need to improve that. Keep into account that the evaluation of your thesis depends a lot on the innovation. If it introduces some innovation, you will get a really good grade. If it's just a collection of collection of data that is already out there, you can put it together and write it in your thesis. That is acceptable, of course, but the evaluation will be lower. So if you present something that is considered innovative, with some sort of innovation, of course, your grade will be much higher. So this is important. Then, how do you provide some innovation? By knowing what's out there already, and then improve that system. Anyway, when you do your bibliographic research, your background research, you will read the work done by others. So you need always to give credit to the authors of the previous studies in the same field. When you read a paper, you need to cite in your thesis, in your paper, the author of the statement that you're writing. So you need to cite every source of information you used in your work. Now, in the academic world, there are two types of written works. So far, I talked about scientific journals, scientific articles, scientific method, and you will be asked to write reports. So the other type of written evaluation is the essay. The essay is not used in most of the scientific fields because the essays is typical to humanity subjects because it's theoretical and discursive, is based on ideas and opinion and so on. In our world, there are no opinions, or better, there are opinions, but we need to state facts. So we need to write reports. Reports are practical, and you will see when you are asked the homework, you will have to write reports. They are evaluative, so everything is assigned a numerical value. Everything that you write has a numerical value. And they are analytical, so you need to face a problem and deal with it. So reports are also significant, especially your homework will be significant because they model academic journal articles. So from day one, from the first homework that you have to do, you will start writing these reports in a way that is similar to how you would write an academic paper. And this means that then by the end of this course, by the end of the 2 years, you should be able to write a thesis already in the format that is accepted and well received by the committee. Of course, for those of you who are not used to it, because you're not used maybe to the academic world, it seems challenging. So especially at the beginning, it seems challenging. Once you get used to it, it becomes natural. It's like driving or riding a bicycle. It's challenging at first, but then you will see that it becomes always the same. Okay, so let's be practical now. Okay, so far we discussed a lot about the theory behind it. Now let's be practical. How is a paper or a report and also your thesis, how should it be? First of all, the title of the report, name, course, and date. This seems obvious, trust me. It's not as obvious as you think. You have no idea how many papers, how many reports I've seen without the name or without the title. It has happened. So please, page one, this is page one of everything that you do. Title, what you're doing, who you are, course affiliation in your case is first level CBRNE master course, and the date. Okay, now this is the actual structure of everything that you should write while you are at Teuberger or in any other academic institution. It's important that your paper always is a summary. In your homework, probably we can skip this because it's going to be just a few questions, so you just answer them. But please, in these answers, keep the structure. So the summary, you can see many words, they all mean the same. Summary, index, table of content, TOC, and so on. They're all the same thing. It's a list of items that a reader will find in your paper. After that, we have the abstract. Now I will explain one item by item, so I'm not going into much detail right now. So abstract, which is also sometimes called executive summary, an introduction, sometimes it's also called background. Then there's the most important section that is called materials and methods, but it's also called procedure, data collection, methodology, and so on. Then we have the results section that is sometimes called findings, discussion, etc. Conclusion and recommendations. And at the end, sorry, a list of references, and if needed, are an appendix or more appendices. Extras that can be added to your thesis, especially the final thesis of this course. A glossary, which is also the list of acronyms or words that are unknown. In technical theses, such as probably will be those that you present, a glossary is important because there are a lot of new words that a reader might not know. So glossary is just a list of new words with a meaning. List of tables, list of figures, list of abbreviations. This is also very important because in the CBRN work, there are lots and lots of abbreviations. CBRN itself is an abbreviation. So every time there is an acronym such as CBRNE, a list of all the acronyms used in your thesis at the beginning of the thesis might help a reader because just a few examples: CBRNE, POD, IED, and so many others that you will see and you probably know. And if you come from the military world, you know even better than I do how many acronyms are used every day. So this could be a very good addition to your thesis at the beginning. Now, based on what's written here, what is missing in this paper? Well, let's go back around. So there is an introduction.
Author name?
Sorry?
Author name?
The author name is this one, Wanderzier Gonzalez. These are the authors. Sorry? The references, probably yes, maybe they're on another page. But yeah, in this page, there are no references. So that's something that is missing. We have the methods, we have the finding, we have the interpretation, which is basically the conclusion. There's one item that is missing.
Date.
Hmm?
The date.
The date is down here,
Okay.
the abstract. There is no abstract. The abstract, we'll see what it is, but it's a very important item on anything that you write, especially your thesis. When you are towards the end of these 2 years, you will have to submit a proposal for your thesis. And how do you submit that? By writing the abstract. So let's see what it is. This is how the summary should look like. Okay, that's not extremely important. Word, Microsoft Word can do it on its own. Let's talk about the abstract. What it is. The abstract is the business card of your paper. Keep in mind that scientific journals often are very expensive. And someone who wants to read a paper might be asked to pay a lot of money to read that paper. How do you know if the paper that you're interested is worth your time and your money? By reading the abstract. The abstract is always public. So what it is, it's a short text that is always at the beginning of every paper, of every thesis, always, it's at the beginning, that summarize the report logical order. So it outlines the purposes, the research method, findings, and recommendations. So in just a few lines, normally abstracts are very short. I'll show you in a few minutes. In the abstract, you have to write your paper just in a few lines. So you have to say, okay, let's say the purpose of this paper is to do this. It will be done by doing this, and then the results will show that. Just a few lines. It's always at the beginning of the paper, always. However, my advice is to write it at the end. You write everything, and then once you have the clear picture, you summarize it and put it at the top of your paper. What's the role of the abstract? As I said, first of all, you as a reader read the abstract of the paper and decide whether you want to acquire the full paper. Now, many papers are published in what is called open access, which means free to read. It's not free for the authors, but it's free for the readers. That makes everything easier. However, papers are long. Imagine a paper that is 10, 12, 14 pages. Do you want to read it all before you think it could be useful for you? You read the abstract and you immediately understand, okay, I could use this, or no, this is going some other way. I don't need this. So it's good to decide if your paper is worth the time of the readers. For the same reason, an abstract is really good for those who will be evaluating your thesis and who will be assigning your thesis to supervisors. If someone writes an abstract on something that is related to radiation protection, radiation dispersion, nuclear events, probably in this master, they will refer the candidate to me or to Professor Malizia. If the abstract talks about a chemical event or biological systems, they will refer to another supervisor. So the abstract is important for a series of reasons, and as a reader, it gives you already an idea of the paper, therefore prepares you for the details that you will find in the paper. It helps you understand where you find what you want. Okay, now another important part is the introduction. This was in this paper here. The background is very short. This is one-page paper, so it's a very short one. Well, the introduction is important because by outlining the context, background and purpose, so your background research goes in the introduction most of the times, unless you want to have a specific chapter on background research. Normally, it would go, everything that you found would go in the introduction. So in the introduction, you should also highlight if there are hypotheses, if there are expected outcomes, especially in the case of an experimental activity. Not all of you will present experimental activities, of course. But in that case, the hypothesis behind your activity and what you expect from the thesis should be written there. So basically, the introduction defines terms and set limits of the research. In very simple word, in the introduction, you will write, I will do, I will do, I will do, I will do this, I will do this, I will do that, based on the background research. So it states the motivation for the work and prepare the readers for the structure of the paper. Of course, the introduction, again, is important for a reader because it gives them an idea of where your research started from. Why did you decide to investigate that? Why are you writing on that subject? So it can be, the introduction is particularly in the way that it can be short or it can be extremely long. That depends on your type of research. Then we have the most important and probably the largest section of your paper, of your thesis, which is the material methods. Sometimes this is also called methodology. It's also called procedure. It means that it explains how you did what you did. Okay? So it explains the research methodology. This is important. Anything that you do, you want to study the effect of a new, what's the name of? Well, you're, for example, applying a new ROVs, a remote operated vehicles, in the sampling of chemical substances from the soil. Okay. Well, how did you do that? Okay. What did you apply? What did you employ? What technology you used? What's that made you understand the issues and solve the problems? So it is a detailed description of all the procedures that were used in your research. Something not as technical. You want to know the opinion of, let's say, victims of a chemical event. You just send them surveys, questionnaires. Well, in the methodology, you will write that you have sent out questionnaires to all the victims of a chemical event to see the psychological effect that they left behind, for example. It doesn't have to be anything technical. It can be something less technical, but still it works in every situation. And this section is what tell readers how you did what you plan to do in the introduction. So here you have to explain the choices you made in your procedure. Keep in mind, most of the times, when you write your thesis, you know what you're doing. All the others don't have any idea. So you will make some choices. Just motivate them. Explain why you choose what you did. Okay. For example, what justifies using a compound, concentration, or dimension rather than something else? What is special, unexpected, or different in your approach? What is innovative of this approach? What is innovative of your approach, and so on. These 5 words are the key aspect of this section. Do not make readers guess. Motivate everything, write everything, detail everything. this section has to be complete. You cannot leave anything as a guess. And also very important is sometimes use tables, diagrams, graphs, rather than write a paragraph. So most of the times, just a simple graph is easier to understand than 1,000 words. It's easy, especially when it comes to complex concepts. You have a diagram or a table, it explains much better than a lot of words. Sorry, just a second. Okay. What I was supposed to tell you. Okay, well, this is again, yes. So in the introduction, what I said earlier was that you should say, I will do, I will do, I will do. Here, you will say, I did, I did, I did. Or better, I'm doing this for this reason, I'm doing this for this reason, I'm doing this for that reason. So I will do, I'm doing, and finally the results and discussions, I did. So the introduction is to prepare the reader for what's going to happen. The methodology is to tell the reader how it happened, and the results and discussions is to tell the reader how you did it. So here you present your findings, the results, especially if it's an experimental activity, you will have some findings, some results, but even if it's just a research with your surveys to the victims of a chemical event, you will have collected a lot of information. You analyze the information, you write the way you analyze the information in the methodology section, but then you will have some results. You will see that 55% of victims of chemical accidents suffer from PTSD, post-traumatic stress disorder. That's a result. Now, this is just random numbers that I'm saying. Of course, I have no idea what's that percentage, but still. The results and discussion is where you present the results of your research that can be anything. Again, it depends on what will be the topic of your thesis. If you want to see the dispersion of radiological nuclei through a dirty bomb, well, you will have some reminder. You will see how they are dispersed in the environment. You want to do just an analysis of terrorist attacks in the last 40 years, well, you will have charts and graphs that show the trends in terrorist attacks and so on. So this part is where you, in a very clear way, present your results, and therefore you state if your original hypothesis is supported or not, if there is an original hypothesis, of course. In the results and discussion, visual tools are very important, are preferable to any other way. So graphs, diagrams, pictures, images. In your presentation, videos, for example, your thesis will be on international CBRNE training exercise. That's perfectly acceptable. As long as you show how innovative that exercise is, you might want to add a video of the exercise. That is perfectly acceptable. So it can go in the results and discussion. Remember that when you will write a thesis. So you have two steps. You first write it, then you submit it, and then you will have to prepare a PowerPoint presentation to be discussed on the day of the final day of the day of your graduation. So always think that you have two steps. The first step is writing the thesis. Once that is done and is accepted, you can work on a 15-20 minute PowerPoint presentation. So should we have a video, which is a very good tool to show. Of course, you cannot include the video in the written thesis, but then keep in mind that during the presentation, during the what's the word I'm looking for? When you defend your thesis, the day of graduation, well, you can show a video because it's always very well accepted. In the results and discussion, you need to state only facts, not interpretation. What does it mean? If you happen to read scientific papers, sometimes it seems like the paper that you've just read is the best paper in the world, and they have provided the most incredible results since the the first man walked on this planet? Well, in the results and discussion, you have to be realistic. You have to also state the limitation of your paper. Your research cannot answer all the questions in the world. So when you write something, you always need to be aware of the limitations of your work. And you want to model, once again, something that I know, you want to model the release of radioactive substances in the atmosphere through dirty bombs. Well, of course, you can do it many times. For example, you can use numerical simulations to simulate the extension of the plume after 2 hours from the event. Well, there are limitations. That is a model. It's not exactly how it will be in the real world. So the limitation of your work is that that's a very good tool to understand in a very short time what is probably going to happen. However, keep in mind that if the wind changes, everything changes. So first responders on field should be aware that the system that I'm presenting today, I cannot always be the best. So facts and not interpretation also means that when you look at a graph, you need to read the graph. You cannot say things that are not there. Okay, you cannot leave readers to guess again, and everything has to be true. You cannot say things that are not true just because they look like it. And your research is not, it didn't go as you planned, that is not a problem. In the research world, if you spend 2 years working on something and it doesn't go as it was planned, it's not, it doesn't mean that you go and throw everything or flush it down the toilet. It's still good, sound scientific work. Motivate everything, explain everything, and facts. So in the results and discussion, basically you report the analysis of the results. Just 1 more second, please. We have a notification. All right. And then the conclusion is again important because it's the closure of your work. It's a brief summary of the findings. In the conclusion, you only write again the findings. There is no need to repeat everything that it was already said. Many times, the conclusion is seen as another abstract. It's not. In the conclusion, you don't need to talk again about the introduction. You don't need to talk again about the methodology. Just brief summary of the findings and relate the conclusion to the objectives. In the introduction, you said, I want to achieve this by doing this work that we'll explain in the next sections. In the conclusions, you will say, okay, I did this and the results support the original hypothesis, or I met my objectives, or I didn't meet my objectives, but, okay? And you should not introduce new information because then it means that you're starting a new work. So the conclusion should conclude your work. This is where the most important outcome of the work is stated. The results are related to the objectives, and you need to show whether you have succeeded or not. Again, it's not important if you have not. If you follow the good procedure and you present the results that even though are not exactly what you were expecting, you reach the conclusion, you can state that, and it doesn't mean that you wasted 6 months of your life. Absolutely. It can also give you information that is helpful for next work for the others. Again, do not restate everything you did. There is no need to repeat everything that was already said. You spend 50 pages talking about your thesis in the conclusion, which is normally a page long, or 1.5 page, even half a page, depending on what your topic is. There is no need to repeat everything again. You just repeat very briefly, okay, in this work we have seen that being exposed to alpha radiation with internal contamination cause lung cancer. Okay, that's what we were trying to prove, it worked. So make it interesting. Who read your paper has read a large number of pages, so make it interesting. Finally, recommendation, this is something that can be or cannot be in your thesis. It depends on the work you do. But it suggests suitable changes. For example, your experiment didn't work, but then you're going to be okay, but this could be done in another way. Right here, it could be a suggestion for the continuation of your work. Action plan for recommendation if required. Most of the times, your research doesn't stop where you write your thesis, it could continue, so write recommendation and in case of future developments. Again, this part is recommended, is not mandatory, the recommendation section. Finally, references or bibliography. Will spend a few words on this, and now I will give you a 5-minute break. So we'll see these later. Glossary, list of abbreviation and appendix. An item that typically go in the appendix if you provide surveys to the victims of a chemical attack. Well, the questions in the survey could easily go in the appendix. They should not be placed in the text of the thesis, but they should go in the appendix. All right, I think we can take a 5-minute break here. And then we'll start again at 10 past 10. Okay? I'll leave these here for Okay, let's wait a couple more minutes. Someone still missing. Ok, I think we can start again. Mi sentite da casa?
Sì, Riccardo.
Perfetto, grazie. Allora riprendiamo. Ok, we can start again. So far we saw the structure of our work. So can you repeat what are all the sections in all better, the sections that are expected to be in your thesis? Of course, there could be more. What's the very first thing that I expect when I read a thesis? Okay, yes, the abstract, yes. Then the introduction, very well,
Material and methods.
exactly. Results, conclusion, yes. And then, in case needed, some recommendations. Very well. Regarding the results section, not all theses might have the result sections, okay, depending on what you do. It is expected that CBR and master student probably will present some results, even if it's the work that they do every day, okay? So it is not extremely necessary, but depending on the work that you present, there could be some important information in the results to be placed. So, okay, yes. So how do you start thinking about your thesis? Because now it's the second week of your class, so you have time to think about it. Even though some students in the previous years started to think about what they would be doing by the first week. So you can already have an idea of what you will do. If you work on already in CBRE, you already know that you will do something probably that is related to your work because you don't want to spend extra time working on this. But how to transform your idea into a thesis, which, keep in mind, it's quite a stressful job. First of all, you need to understand your audience. Who are you presenting your thesis to? In your case, you are presenting your thesis to the university's commission, which is made mostly of academics, but also some experts of the field. So keep in mind that your thesis will be read by people who generally understand what you're talking about. So you can be technical or you can be less technical, depending on what you're writing, but keep in mind that your audience is generally people who have an idea, at least. I myself am not a biologist. If you present a thesis on the biowarfare agents, I might not be the best to understand it, but at least I have an idea of what you're talking about. Okay, so keep in mind that your thesis will be read by people who have an idea at least of what you are presenting, and anyway, in our team there are experts of every field. Then you need to think about the purpose. Why am I doing this? First answer that usually comes to this question is because I'm working on this and I don't have time to spend on other topics, so I will do this work. Besides that, the purpose is what should drive you in writing your thesis, in working on that research. Okay, why do you want to investigate that? You might be a firefighter working on the CBRN team of the firefighters, but you might want to work on biowarfare agents because you're interested in that. Feel free to do it, of course. What's the purpose behind it? Then you will need supporting materials. Supporting materials is the background research, but it's also other materials that you can find. For example, if you talk about a European project of improving the training of first responders, well, you will need the material, access to the material from the project in order to better understand what they do. So in these, we can help you somehow, especially when it comes to scientific papers. Please, if you don't find something that you really think you need, come and talk to us. We might be able to provide you with some supporting materials on that. And most of all, last but definitely not least, time. You are all workers. You don't have that much time. Keep that into account when you think about your thesis. We'll see this in a minute, but writing a thesis, if it's done properly, if it's done well, takes time. So keep that into account when you do your work. So the first step of your mental process is to set up the aim. The aim is the intention, the aspiration, what you hope to achieve with your work. So aims are statements of intent written in broad terms. For example, I'll give an example. So they tell you what you hope to achieve at the end of the project. For example, you want to achieve the investigate the relationship with the tectonic plate movement and the gravitational effect of the alignments of major planets. Of course, this is not something that would be in a CBRNE master course, but this is just to give you an idea. This is the aim. It's quite broad. Then you have to set up the objectives. The objectives are single goals or steps that will help you to reach your aim. So objectives are smaller than the general aim, okay? They use specific statements that define measurable outcomes. For example, what steps will you take to investigate the relationship between tectonic plate and the gravitational effect of the alignment of major planets? So your aim is, it's a broad, large object, and then you split up into small objects or objectives, sorry. All right, so in a few words, you need to be smart. You need to be specific, measurable, achievable, realistic, and time constrained. Specific, be precise about what you are going to do. When you start thinking about your thesis, try to have a precise idea of what to work on. Don't waste too much effort and resources and time on everything, but focus your attention on one or two aspects. You will figure it out as you go. It's still a long process, but try to be specific. Measurable. Everything that you do must have a sort of evaluation. You have to evaluate yourself. You have to measure your progresses. You know when you reach your goal, but you need to know every single objective, every single step. You must understand where you've reached the objective, because if then you stop working on that and you can start working on something else. So you will never stop. Something also that relates to this is when you write your thesis, do it, then you read it again, then read it a third time, and that's it. Don't read it over and over, because every time you read it, you will change something, and then you cannot be measurable. You cannot ever reach your goal. So try to write it directly the first time in the best way possible, so that it's done and you can move to the chapter. Okay, this is done. Now you can pass to the second chapter. Because if you start reading your thesis again and again, every time you read it, you will find something that you don't like and you will change it, and then it takes forever. So start from the first draft, write it as best as you can. It takes time, but at the end, it will save you a lot of time. Another aspect is that what you're doing has to be achievable. This is a common problem. Many students, not only in this course, but in every course, try to achieve what is impossible. And trust me, it is much better, less ambitious, but completed objective rather than something that is left halfway to the end, because it's impossible to achieve. Okay, if your idea is to prove that I don't know, that every single exposure to radiation causes cancer, you know that that is impossible to achieve in a thesis in a few months. So try to be less ambitious, but reach your final goal. That is more important than setting up goals that seem great, but that you cannot possibly achieve. Realistic, this relates to the being achievable, but this is also, do you have the resources to achieve the objective? You want to test how good the gas masks seal in a contaminated environment. Do you have access to masks? Do you have a chamber where you can test your mask? If you don't, how are you going to do that? So you have to be realistic. You have enough time. That's a big problem. Money, we hope you don't need any money to do your thesis. Skills that I mean, personally, I will not ask you for any money for your work. So, and I hope that you will not need to use any money, your own money, in order to write something. Okay, so maybe if you have access through your work to some particular materials that you need, that's good. Otherwise, limit the money, because we are not asking you more money than what we ask already. And skills, that I don't know, that depends on you. I don't want to judge your skills yet. I have just met you, so I'm not going to do that. But so be realistic. Do you have what it takes to undertake this challenge of writing a thesis, or that particular thesis? And finally, time constraint. So you don't have that much time. So use it properly, use it well. Schedule your work. Give yourself a calendar. For example, when you start in, let's say, 1 year, 1 year and 3 months, 4 months, 1.5 years before the end of this course, plan objectives. Okay, by next month, I have to be done this. By the following month, I have to be at this point. That will help you to plan your work and arrive at the end without too much stress. So you need to be aware of the skills required. When you write anything in the academic world, you must be clear and concise. So do not write 10 pages if what you're writing can be written in 1 page. You need to have a good eye for detail. The committee often focuses on very simple details that seem not important, but they will stress it significantly. For example, in my case, if I will be the supervisor of your thesis, I will ask you to be very careful with the references and the citing system. We'll talk about it now, but it is important when you write something that stays in the archives of the university, that has to respect a certain set of rules. In many theses do not, but that depends. I mean, in my case, I will ask you to be careful with that. Most of the times I will not ask you to change the content of your work, because that's your work, but rather the format, the appearance of it. And of course, you need to have a knowledge. If anyone asks you something about your work, you must be able to answer. Okay, and finally, this is how a normal paper looks. I don't know if you will be provided or not with a template for your thesis. If not, I will give you all the instructions that you need to write it. We used to hand out a template, but then we realized that it didn't work and it was messing up with all the thesis, so probably we decided not to do it anymore. but we have templates of every format. So if you need template that is just a set of font size, interspace, and so on, please feel free to ask, and we will provide you with what you need to write a thesis that looks like a proper academic thesis. This one is a paper, of course, that was published on Fusion Engineering and Design. As you can see, title, names of affiliation, the first thing that you read, the abstract. This is public. So if I go online and look for a paper on this law, we don't need to know what that is now, but I want to see a paper on law or on computational fluid dynamics. I go on Google and ask for it, probably it will show me this journal, and this journal will show me this abstract. So I read the abstract and I'm like, okay, I'm interested in this paper. Maybe I will buy it or I will acquire it through the university. Keep in mind that as a university, we are able to acquire, to get many journals, many papers for free. So if you are asked money for this, please come to us first and we will download it if available, and then we'll give it to you. So first thing, abstract. This is the business card of your paper. And in your thesis, this is what will decide your supervisor. So that will assign you to a certain supervisor. Okay. And then the paper, okay, this is just to show up looks. What time is it? There are many reference style systems. Reference style is, you can see it here probably. No, not in these. Anyway, every time you cite work that was done by someone else, other paper, you need to cite it. You need to write that that sentence was taken from some other work. There are many styles. The most popular is probably Harvard, and I will give you a couple of links to download the Harvard guide for citing. The APA is also popular. The IEEE is used in engineering and technology. For example, my background is in environmental engineering. Most of the papers I write use the IEEE system. But MLA thesis for humanities, probably most of the times for literature review and so on. And these others are all styles. One thing that I want to tell you is that it does not matter which one you use. They have all of them have a large, huge set of rules. And they are different one from another, but it doesn't matter which one you use, as long as once you use one in the paper, you always use the same system. This is not important, we can skip that. Okay, through these links, and then at the end I have a page with all links. You can download the Harvard referencing guide through this link from the London Metropolitan University. From this link, you can download the citing and referencing using the Harvard style from the Imperial College of London. Two colleges, two universities from London, because they pay a lot of attention on citing, so their guides are really, really good. This is the template for MLA, where you can write all the information of the papers. And these are a few good websites with tips and rules for this citing style. I will go now into more practical to show you what I mean. But these links, and you will be given the presentation, so you can click on them, will provide you. Let me just click on one of these to show you what it is. Okay, for example, this Purdue, which is a good one. Let me see. OpenStreet. Okay, this one is the Writing Lab of the Purdue University, and it has a series of instructions on how to cite work. For example, the IEEE style, it will give you the overview, the format, the in-text citation, the reference list, and so on. So it's a very good tool to understand how to cite the work. Okay, now we are concluded with the PowerPoint. Do you have any questions so far? Have I been clear? Too much information? Okay, good. Now, I want to show you a couple of things. Let me just find everything. Okay. Sorry, but we're working with two screens and it's not very easy to follow one. All right, this is a paper on the journal Applied Energy. And as again, you have the title, you have the affiliations, here it shows the highlights. This is not something that every journal does. Okay. Then, of course, you have the abstract. As you can see, the abstract is always a single paragraph. There are no references in the abstract, and it's just a summary of the paper. So you have a little introduction, 1 line, 1.5 line. Then this work presents novel, so what this work does with these methodologies, and then at the end, the developed methodologies adopted to design this final system behavior is revealed. So you have the context, the methodology, and the results in just a few lines. This is how the abstract must look like. Okay. Again, this goes always at the top of your paper, write it always at the end, except for your thesis, because that will be what we need in order to accept your thesis. Then, if we go on, we have the introduction. Here we have a table with all the acronym, the glossary, and so on. This is still the introduction. Then we have system description, formulation of the optimization problem. So this is the methodology. And finally, the results somewhere. What I want to show you is deciding, okay, so when you read a paper, you always find these little numbers here. These are the links to the sources that you have used. There are different types, as we have seen. When you have a number that links to a list of sources listed in order of appearance, this is the IEEE. IEEE. Other times you have, instead of a number between square brackets, such as this one, you have the author and the year. And the reference list is in alphabetical order. That is the Harvard. Choose the one that you prefer. The Harvard is good for one reason, because being the name of the first author and the year, if you need to change the order of your references, you realize that, where are we? Sorry, it's complicated. Okay, here, as you can see, there are a lot of different references, right? A lot of different citations. If you realize that you want to add something here, for example, with the Harvard, you just write the author and the year, and the list is in alphabetical order. So you just add here the name and the reference at the end. With the IEEE, you need to change all the numbers of the following references. So it is easier because you just write 1, 2, 3, 4, 5. They have to appear in order, so you cannot go 1, 5, 6, 3, 2, but they have to be in order. The problem is that every time you add something in between, it changes everything after that. How to solve this problem? With Microsoft Word. And I'm going to open Microsoft Word to show you how this works. So you always have to write in the text, you write the reference, and then at the end you place the list of sources, okay? This is something that if I happen to be your supervisor, I will be extremely careful with that. Yes. It's the same, yeah, but you have to use the same system. Choose one referencing system. It can be APA, it can be Harvard, IEEE, it can be Chicago. It doesn't matter as long as you always use the same system. So it's consistent, and with LaTeX you can instead of Word. I don't know how LaTeX works with references, but there must be a Yeah, so it's generally, if you know to write in LaTeX, it's easier there. Okay, so you don't see it yet. Here we have Word. Okay, Microsoft Word is the, again, sorry, it's the most commonly used Word editor software. If you go here, wait, I'll place this in English first. Good. Just a second, I'm changing Word in English, so. Okay. Now it should probably be in English. Yes, it is. All right. So when you write something, for example, just writing randomly. And write. Okay, this is just a random thing that's running. Okay. But then you want to cite this. You found online that the Chemical Weapons Convention was signed. I don't even remember the year, so don't look at 1987. That's just probably wrong. But then you want to cite this. Okay. You have found online that the Chemical Weapons Convention was signed that year. So these must be cited. Okay. In Word, you have this tab here, references. You can insert selection. As you can see now, there are no sources. So you add a new source, and by selecting here, you decide if it's a book section, journal, periodical report, website. I found it on the website. And the author is, here is, let's say, it was me. Now we have the author, the name of the web page. Don't use Wikipedia. Sorry, no, this is the website. The web page, for example, is Chemical Weapons Convention. The year is 2005, 6, and here the link. Okay. Now, as you can see, it placed it there, and you can click on it. It shows you that you can edit it. All right, now we have done the first one. This is the APA side. It looks like the hardware. You can select different styles. For example, you can select the hardware. It looks the same. You can select the IEEE, and now you have the one. So you don't have to do it manually. This is important. Keep that in mind. It saves you so much time. It takes longer because you have to enter every single reference when you add it. But then let's say, okay, dog's bark. Okay. Where did I find this? I found this again, citation, a new source. This is from a journal article. The author is, let's say, is Malizia Andrea, Professor Malizia. The title of this is Dogs. Well, Dogs. Journal name is the Journal of Dogs. The year 1999, volume 12. For this information that if you have it right, about you don't, it doesn't matter. Okay, that's number 2. At the end of your work, you add a bibliography. For example, bibliography, references, works cited, that depends. These are pre-made. So I like references. And here you will find the list of references. Self-produced. Now I realize that I want to place this before the other. All right, good. What do? I go to the single citation, update, and it already blocked all the sources for me and updated all the citation numbers. So this system is helpful. Of course, then if I need to cite again docs, here I will find all the list of sources that I've used already. So I cite this again. And it will appear here automatically. So you can also recall old sources that you have used. Keep in mind, if you use the IEEE, they have to be in order of appearance. Okay, so you will see always first number one, number two. Then if you want to use an old one, you can number one, number two, number one again. But in the reference list, they are always in order of appearance. With Harvard, I don't like IEEE anymore. I want to use the Harvard or the APA. Okay, you have the name of the first author, and then they appear in alphabetical order. So with Harvard, you don't have to change all the order again because it's always the same. With IEEE, you have to change the order every time. So this word tool works very well. Want to use the APA, it's similar, it changes the information that appear on the reference list. For example, APA shows you the author, the year, the journal, the paper, the journal, the volume, and the issue. And Harvard shows the same things in a different format. Okay? All right, now very quickly, I wanted to give you a small exercise to do in group, but we will. Okay, no, it's not this one. Okay, this is a paper that, based on what we said now, we don't have that much time. Sorry, I lost the mouse here. I'll leave this as a homework, okay? Very brief thing to do. You can download this paper from this link. I'll send this link to the WhatsApp group. So what I would like you to do is to have a look at that paper and find out if there are big mistakes in the structure, in the content of the different chapters. Okay, so it shouldn't require very long, it's just 10 minutes. So to see if that paper is written according to what we said today. Okay, let me just share the link on the WhatsApp group. If you see something that is completely wrong, please let me know. That is important. Just to check that what I said today is clear, okay? I will send the link to the WhatsApp group, so. So please keep in mind that this assignment that I'm giving you, it's not mandatory, okay? You don't, you don't have to do it, it's just for you if you want to understand better what I said today. It could be a good way to. Here, and this is the first level. First level here. Okay. Now you should have the link available here. Okay, so very briefly, let's go back to it. Okay, so here you will see this paper. It's on zero emission rate traction. It has nothing to do with CBRNE. However, in this paper, you will see the structure, you will see that there might be some issue with it. If you have time, please have a look and let me know if you find something that should be improved before this paper is published. This was a draft submission, so as it was never published. Okay, it cannot be published because there are a few issues. If you have time and if you want, please feel free to download it, read it, and find out what those issues could be. And let me know. I will also give you my email address so that you can send me an email to tell me the issues. Okay, that's my email on WhatsApp. So again, you don't have to do it this week. You can do it anytime you want. It's just for you to test your understanding of what we did today. All right, I think it's enough for today. I believe I gave you a lot of information, especially if you are not in the academic field. This could seem like a lot. So, sorry, Professor Malitz is calling me. So, I will just stop here, give you a few minutes break before Dr. Simone comes and we'll start the biological part of this week. All right. Should you have any questions, please feel free to write me on WhatsApp or my email address. Thank you.